Hi everyone, I am trying to demonstrate functional prototype of home automation over next generation IP known as IPv6. The reason behind why I choose IPv6 is that it has large address space that address IPv4 exertion problem, and it is easily scalable, and it has simple header structure design and hierarchical addressing model that makes it suitable candidate for wireless embedded network. First of all, I will explain my lab setup. Here is my lab setup. I used Raspberry Pi board, and these are the Raspberry Pi board and Wi-Fi IEEE 802.8.11n wireless module, which supports standard 2.4 GHz spectrum to build our home automation over wireless technology. First of all, I compile Raspbian operating system with IPv6 stack in order to support IPv6 in WLAN interface of Raspberry Pi board. For our demonstration, I use 3 Raspberry Pi board. This one is my coordinator, which communicates to the service provider IP in one interface and communicate with rest of the node through LAN network with LAN interface. The one interface is connected to the service provider router by Ethernet cable to communicate with outside network by setting port forwarding rule. And LAN interface is being up by wireless USB module to communicate with other node over standard IEEE 802.11 wireless technology. And this rest of two board are configured as a end node. One node is connected to LED and another node is connected to DC motor that are connected to fan, and this board is connected to LED light and which is workage light. Here I use IO pin 12 to connect to the hardware and IO pin 6 to connect to the ground. And the setup can easily extended by putting relay switch to control rear light and fan, and some other home appliances such as like washing machine or TV, fridge, anything you can extend it by using another board. Now I will see our software that handles the devices. The core module of the middleware and the application are developed in standard C language and shell script. So for each board we are running a home automation app. That app it has a device config parameter which will be configured so that a node can be acted as coordinator or end node. Here first I'll start my coordinator, and so the coordinator is configured from PC through SSH. So I'll start my coordinator. So to run the home automation app, it needs super user. So I need to go to the super user mode. So if I'll see, this is my home automation app, and now I'll run this app. So my coordinator is now started, and to communicate outside the network through web app, so a web server is running on the coordinator. Now we need to bring up another two node. So I'll bring up my node 1. So this one my node 1. See, so here also we need to run the home automation app. Before running home automation app, we will see the what is the IP is there. So See, this is just a local IPv6 address. Till now, it does not got any IP address. So once I'll run the home automation app, so it will try to request the coordinator to get a IPv6 address. Okay. Now this client, my node 1 client is already started, so we wanted to see what IP address it got from the coordinator. For that we will go to another window, because I am not able, I will not stop that app, so as it is already running. So see this. Okay, if we will do the config, see, this is the global IP, this is the global IP that is assigned by the coordinator to communicate to the node 1, and the coordinator maintain address mapping table for further communication to send the data. As we have two node 1 we have configured now, then we need to run node 2. Node 2 need to be configured. So node 2. Similarly, here also we need to run home automation app. So now already my two nodes are already started and coordinator is started. And if you wanted to, we will see also what IP it got from the coordinator. For that, okay. So now we need to do config. See, here coordinator is assigned this address to it to communicate, and to control all the device through the web app. We from the mobile smart device we need to control these devices. For that we can go to the web browser. Okay, we'll go to the web browser. Need to refresh, sorry. Okay, this is my web browser. As I have only connected to two devices, so I created the interface with only two devices. It can be extended to any device. So I need to switch on. Currently, as both are switched off, so we will send a on command to both light and fan. So need to submit. So you can see both my LED and my fan already started. Then now again we need to switch off both. Submit. So you can see there is delay. I have put some delay, and as well as there is some network delay. Because of that the response is this much time taking. So now we can switch on one and switch off another. So switch on the light, and Its fan is already switched off, it's okay, we can do that. So you see, so now my LED is off, sorry, LED is on and my fan is off. And if by some means if the app is suddenly closed, then it will send automatically a off command to the device. Suppose my node 1, if I do my node 1, if I do I means I'm okay. Okay, I'll send oh sorry, I already my fan is off. If I'll send if I'll close my app, it will not cannot detect the fan and again off. So this is my light window. So when I send the command, I stop the app, but automatically my LED is off. And here each device is using UDP IPv6 socket to communicate with each other. And for my future work, I am planning to use MQTT and COAP protocol to communicate RESTful network to build a smart home. So thank you everyone for watching my video.